I'm the operator with my pocket calculator.
Good morning. Instead of an introduction, I show you all my slides in a slap video in 3 minutes. There are all the slides with all the, let's say, the different things I could show. I cannot show everything, and I can't even follow directly. This is from abacus, from hands to abacus to adiators, from different kinds of dial adders like Pascal-like or something, and of course adiators. In the whole there are about 40 different instruments, and this is a very introduction, and perhaps after the 3 minutes you have already seen all and can leave to take a coffee, because I will speak all about these things. There are some interesting items which perhaps are not even known to specialists. For example, of adiators, something is very well known. I cannot go very deep in the details of technical explanation. But what I will show is how I, as a collector, had to learn and to use it. And I filmed during the use of some very simple calculation. For example, here the Otis King, you have to do this beginning over there. And all the things you saw at the first slide, you saw an internet site where you can see all the things here. I cannot take it directly from the internet site, perhaps, because I didn't know how much the WLAN is working, and I have it on a stick, and it goes from a stick. As you see here, this is a very simple calculations or simple demonstration of the machines, how they work. When you are looking attentively, you may even think of how you yourself, perhaps you have the instrument and you used it. And perhaps seeing my presentation, perhaps you may have some idea how to, let's say, complete your collection of slide rules with some of these instruments which can be found sometimes, let's say, in flea markets, but not in flea markets. It's very difficult in eBay or something like this to buy them. Of course, you see there's a little bit, yes, a historical review from very simple devices, or not even devices, calculating aids, let's say, until the last, as you see here, the Corta is coming. Yeah. No, whatever. This is no. And now where is the first? No, this is. No, jetzt. Habe ich den verkehrten zugemacht? Ja. Ja.
Mal so.
Wie kann man denn den letzten? Index. No, this is. Yeah. Now I already made some explanation. What I'm interested in is the form, some characteristics, aesthetics, perhaps advantages and deficiencies, some description, and what to do with this. Perhaps it's interesting, the first calculating device is, of course, portable calculating devices, our hand. What I'm very interested is to be able to explain didactically how can be used the fingers. And I found in the number theory site, this is an Indian sect in Kerala, how they counted. They count differently from all the others, you know. And they count like this. This is 0, and it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10, of course, is like it is. Excuse me, is like this. Yeah. And now a little bit examination. What is this? Yes, this is 77. This is very interesting because using this finger counting, let's say it is more than a counting, perhaps even more an indication how for faraway persons, when you're betting or something like this, to indicate what you are betting on. Perhaps you can even calculate, count from one number to other, like a little bit in an abacus. Of course, the abacus had a long historical trail even from the Sumerians and Greeks and the Romans. The name even is from the surface. The Greeks put on some lines and put on pebbles, and the Roman continued in the medieval age. They used some tables, perhaps clothes were clothes from leather or cloth, where there were some lines, as you see here, and they put some pebbles or perhaps jetons or Rechenpfennige or jetons on some places, and there was an indication where to do it. Unfortunately, these clothes or these pebbles are not even known very much from even in museums. You don't find it. I made a little acquisition via eBay company, and they sold me a medieval counting board. And there I would like to show you how you count some very simple, let's say. Yeah, you put the jetons, here are little wooden pieces on the board. I do 188 plus 2. This is very simple, and I made it all around in these simple calculations. And you have to put it from one side to the others, and you have always to be thinking about what you are doing, because you have to do the tens carry. Not even the tens carry, here is a 5 carry, let's say, because you have only up to 4 pieces in one, still up to 4 pieces in one row, in one smaller, up to 5 rows. When they are 5, you have to put them away and took the next to the tens, and so on. There are even some possible some calculations, a little bit difficult calculations. For example, multiplication. I'm not really able to explain it here at the side. You find in the book, you find the indication, multiplication with, let's say, small numbers, which have been done with this reckoning board. You have to have three departments, let's say, where you put the pieces. In the first two, you make the multiplicand and multiplicator, and you have only to know doubling and dividing by 2 and halving. And with an algorithm, you put the numbers, the first, you do the halving, letting away the 0, 5 if it's an odd number, and at the right side you do the doubling, and when you have at the left side an odd number, you add the point at the right side. This is mysterious. It was the first mysterious. I'm a mathematician. It was mysterious for me, but it's very interesting. You have a look there. I have two in the book. I have 2 multiplications, 13 by 12 or 12 by 13 to see the difference and how it works. It's a little bit abbreviated, but you may see how it works. Yes. let's go on. Of course, the development of this reckoning board, let's say, with movable pebbles, has been already developed by the Romans, the Roman abacus. Unfortunately, there are only 3 or 5 really left over. This is even for archaeologists, this is very strange. They don't know why so few are have survived. I have this is here in the left here. You have this Roman abacus. There's even a relief where a servant is using this table or something of this table. Of course, the development of all this are the Japanese and of course Chinese developments. Perhaps I've gone over there. Yes, all these function more or less in the same kind. You have in one row the units up to 4 or 5. It depends on the development of the abacus. And in China there is more the use of another kind. This is more the I don't know what, perhaps it's over here. Oh, this is good. This doesn't go automatically. I call it 5-2 abacus, where you have in one row 5 units and 2 indicators for 5 units. Of course, the problem is when you see it here, then when you are counting this simple counting, you have to do a little bit sophisticated tens carry, or let's say the reversal of the result and the direct result of counting, only adding one pebble after the other, one beat after the other. You have to do to return to the canonical form. Canonical form is the beginning or the end of every calculation. Here you have seen the calculation with one of this. This is another. This is a 5-1 Soroban. Development is more used in Korea, and you have 188. And if you add 2. You have to 0 the 5 and add 1 at the next position. All this, of course, is one of these interesting things I always say, which is an advantage, I say, of these hand calculating devices, and a disadvantage. Advantage, I call it advantage because you have to think with what are you doing. Yeah, you have to reflect what you are doing, even sometimes to count, let's say, aloud. You say 1, 2, 3, 4, plus this, and you have to memorize the redoing of the canonical form, or the tens carry, let's say. Sometimes the tens carry is very difficult. If you have 999, you have to do one of all the rows. But even if you have perhaps seen in some yeah, I can say YouTube video, you can even see some children using these abacuses. Even without the physical abacus before them, they are doing it so mentally. They know where they have virtually met some beat somewhere to do even multiplications. I think it is not these are not fake videos, but I really recommend to see it. The other development of this kind of calculating is the addiator. One of the first addiators is the tronchet, arithmographe tronchet. This is very interesting because it's used a little bit different than all the other ideators, more developed ideators. For example, you have two indicators of the numbers above and below. And of course, when you add, you put the pen inside and pull down or up, and around the crook to do the tens carry from one position to the other when there is necessary a two-position carry. This is a little bit more difficult. You have to add 0 at the next position where it's coming out a red light. Unfortunately, this is one you can even subtract. Here's the subtraction. But the subtraction is really interesting. You cannot do addition and subtraction in following. You have to take the result of the addition and put it upside to the, let's say to the negative point, which at the beginning was 999 and there was 00, but perhaps this is always the tens carry. And then you add it, then you use it in the same kind than the addition. And of course, when you are adding at the negative part, there are subtractions. Later, ideators have developed some very more sophisticated possibilities. For example, the correntator has, and perhaps you see when I'm using it, I'm accustomed to use it, but you have always to tear a little bit, and they are rusted and sometimes a little bit hard to reset. The correntator has a very sophisticated indication. In the half of the 5, you have to flip around a little bit a piece of a sheet of metal, and they have at each side different numbers, and so you can, here's the addition, and when you have to do the subtraction, yes, you flip this sheet, yes, you flip it like this, and when you are at the minus side or the subtraction side, and you do the same kind, only that the crook is at the other side, is above. Now this is very interesting. Other developments made this same thing with more, let's say, different methods. For example, the ideators, or some of the first ideators, made it at the other side of the ideator. And when you do the addition, yes, you are the addition side. And when you have when you want to subtract, you go to the division side, division or subtraction side, and you do the same thing. The crook is always above, because when you flip it off, the numbers are going in this kind, what you like. Yeah, yeah, we have some others, ideators. Perhaps a very strange ideator is I call it, this is not really known, the crypto ideator. For some friends of our meeting in Munich, perhaps they know it, we spoke about it, but it's interesting. This is a crypto ideator. What means crypto ideator? Yeah, as you see, this is an ideator, but instead of numbers, you have letters there. And I'm doing a calculation, a very simple calculation. I am adding a series of A.11, let's say. Yeah, and above there is a result, let's say. A series of numbers is 1, A, B, I don't even know. These are the result, A, okay? When you flip it to the other side, to the subtraction side, of course, you can imagine when you subtract the same numbers, it should be the result at the beginning. Yeah, and now we do 1 and A. We search A, and of course we have to do all the tens. Yes, yes, the carry to the next position. Let's say, but it is not tens carry. And yes, and the result is 0. What is this kind? We don't really have a real explanation. The only explanation may be that this is an adiator, which in the first times of the caches, a little bit, perhaps still mechanical caches, had the problem at the end of the at the evening. The people, the service people at the caches, could eventually cheat something or have some problems to have the result, and to communicate it to the manager. They had to see the number, what is the result, the end result, and the manager has to go around to the different caches to sum it up. But my interpretation, our interpretation is this is a little bit, yeah, let's say the lack of confidence to the personnel. Perhaps they could have cheated or even did some errors, and at the end of the evening they had these caches. No, not even the manager. There came out some list of numbers, and the manager took in the numbers and could control then afterwards, because the manager knew what are the decodification of this. This is not so very difficult, the decodification, but they could do it. And but the personnel could not so simply, let's say, cheat. They had to take the numbers over there. They couldn't give some other numbers, perhaps to conceal some differences between the content and the calculation of in the cache. Yeah. This is I call it crypto adiator. There is only, let's say, only two new Distelbach in Distelkamp in Munich has one, because I found it in a flea market, two of them. One I gave to Distelkamp and one I took with me and presented here. Yeah, I won't lose much time about the Faber-Castell, one of these slide rules, which at the other side has an adiator. Perhaps you know what an adiator is. I think you know what how is to be used. The slide rule. Perhaps this is interesting to see how you can do even multiplications, let's say, with an adiator. You have to, when you see I do it 23 multiplied by 5, you have in each position you have to take 5 times the 20 and 5 times the 3, and of course you have the result at the beginning. But it's not so easy, because you have to think of the tens carry. That means that, and even when during the doing of this multiplication, you have to speak aloud 1, 2, 3, as you saw the numbers here, 1, 2, 3, because you don't have an indication what you have immediately done. This is one of the interesting thing of this. Let's say of these old instruments, because you have always to think about what you are doing, and you have to do some even simple simple actions to do the tens carry, and perhaps some counting intermediate thinking of the counting. Yes, yeah, perhaps you know, perhaps someone has seen, this may even be, a slide rule may even be on a pen, but it's not really very useful, because the precision is not so very good, and even the use I didn't really use it very much. Of course, interesting are the disposition of these logarithmic scales, of the two logarithmic scales in a disk. You know it, yes? The simplest one and cheapest one, someone was this Tröger disk. And where you have behind, you have a knob where you turn the inner wheel, and you have even no indicator. You have even no cursor to indicate the result. You have to search it nearby the value where you are interested. More. Yes, more, I can say. I don't know if it's really more sophisticated, but it's interesting. This is this small device, the calculimètre, the Charpentier. You see it, it's really a little bit, it is so small that it's even difficult to film the using, and it's always difficult to adjust to the right number and to avoid parallax errors and so on. It's always the same calculation, 23 multiplied by 5. Yes, and when you have to search it with the indicator outside, I saw it, mine is a little bit functioning a little bit different than someone had one. Yes, the Thomas had one. It's functioning a little bit different. There are different versions. Even mine, I didn't find it in the authored specialty session, but it's not so important. The different kinds. The calculigraph is naturally is a very sort of instrument. Even in the last time I saw it, it is not even so expensive. I don't know why. Once I think of the first I bought was very expensive, and in the last year I bought one for not even 100 euro. The functioning is yes, let's say the functioning. You do the indicator to the one position and turn the upper knob, and then you press the side button and turn the indicator to have the result, and the result is over here. It's 150. As you see, even filming it, there is some parallax error from this different distance between the needle of the indicator and the indication. This is really a problem of all these kind of instruments. Of course, perhaps you know the Otis King. I have here this one 423, and I must say I made the little film to remember myself, because it's really not very difficult to use it, and I fear in the paper there is let's say a little error. This is it has been described a little bit too simplified. Here you see what I made at the beginning is simply calculating by one to see how it calculated. In the lower indicator, you put a number and look over there, and where the other indicator at the other side is multiplied by 1, because I set at the beginning 1 and 1 upside down. Now I do it this with 4, for example, and we do upside, we look, and 1. Yes, this is only didactically. It's even to remember that you have to do it at the down and upside, and pull the intermediate tube down and up. Now I do this calculation at 23 multiplied by 5, and you have to search for 5. This is always a problem with the length. Sometimes you have to search in one direction and the other. This is known from the reverse, or from the Durchschieben, as said Kleine. and you have the result. Look over there, and then of course, if you have the result at the bottom, you can do simply the division. The division is the reverse of the same action. You search over above the number to 1. Yes, and below you have the result 23. Yeah, this is. I recommend, if you saw the website at the beginning, perhaps when you see it, what I'm doing here, I'm always clicking. This is a very simple, small, simple websites, and when you are looking here, you see the cursor is changing. Will open the film. At one of these of our Munich meetings. A friend brought something I really, I'd like to have it, but it's so rare. This is called a multi-rex or multor or something like this. This is a very small, very, let's say, pocket device, a small pocket device where is realized the whole series of Napier bones, the numbers of Napier bones in the right ordering, and you have to flap over to the right the multiplicand and to open the small windows over there. Perhaps one could repeat it. But we do this multiplication at the right. We open at 2 and 3. At the 2 positions, and to the left we open at 5, and below we see 15, and at the 10th position we see 1, 0, and of course the 0 and the 1 has to add it, and we have 115. Yeah. I have to repeat it. If you like to have it repeat it, you can see it. Perhaps we can, when we speak about, we can later on continue. Yes, a little bit. This is not a calculating aid. Are these rods developments of the Genaille of the Napier bones? Genaille, Lucas have developed a very nice. Method of multiplication and division with these rods to make to do at the upper side you to take the strips of the number, and below you have the multiplicand, and you have to for the multiplication you have to follow the triangles. And for the division, you have to follow the smallest line going out. Yes, the developments of this kind of calculating devices are these different, let's say, odometer. I call it odometers. All these kind of Pascal-like they are called. They are dial adders, where you are dialing like the old telephone. Numbers, and of course this is very intuitive how to calculate with this. Perhaps it's less intuitive to do subtraction, and one of these problems is of course the smoothness of the tens carry, because they are using a little more or less developed method of already invented by Schickard with one tooth at the 9, let's say the 9 position, which carries on the next position for the tens carry. This exacta is yes, is a very nice instrument. Perhaps yes, there are plastic devices. Yeah, we can see one of this. It's perhaps interesting. Of course, there is a provision to do the subtraction simply to invert the direction of the dialing. And a little bit like the addiator, but there is even a problem because, of course, the tens carry must be inverted too. And this is not always so easy, but some device like this Pascal type is even transparent, and you can see, let's say, perhaps it's didactically important to see what intermediate levers have to be moved to do the tens carry. Yes, one of the oldest of this kind is this calcumeter. This is not really a pocket device, which is so heavy, but I took it because it's interesting, because it's so old, and in the display I have there's an indication. They advertise it with it lasts a lifetime, and really it lasts a lifetime. As you see it, I did you see the tens carry? This is so fascinating. I re-show it to you. Yeah, I do 9. The numbers of 9. And this is one of the let's say the experiments to see how a calculator works. You do some 9s, and perhaps more sophisticated machines like comptometer, let's say, big machines, you have to do it, and you do +1 and you see, of course, there must be, as you see it now. Yeah, you see, this is really this is interesting how internally some springs provide a successive succession, let's say, of the tens carry to the last position. Yes, this is, for the rest, it's not so interesting. Interesting is perhaps a little bit very, very miniaturized kind of this dial adders. Unfortunately, I can. This is not mine. In one of the Munich meetings, a friend brought it and showed it to us, and let me photograph it. Not even used, because he feared I would break something. You remember? They were lucky to have even a photo. This is a small key where you put in the numbers and do the dialing. Let's say the dialing is for to count the pocket money one has over there. Yes, of course. Let's say more general, more simply counters are this web adder and Stevenson. Stevenson has only to count till 20 pence. Yeah, 20 pence, and I can do the same calculation when you can see it here. This is, of course, it's 80 plus 18.8 plus 2 pence. Yes, it goes to the next. It was one of the origins I used it. A little bit another kind of calculating devices is this kind of ADDICs. These are column adders where you can count only single digits, like you do it when you have to sum larger lists of numbers, and you do it for the units and tens and so on. And of course, you have to remember the intermediate results. More sophisticated have a bakelite case around, and development. This is not really a portable device. It's this coolie where you can even avoid to write down and to write down the intermediate result for each column, because you have a carry to go it on. But the principle is always the same. In the STEMA is a Swiss development. This is I find it interesting because from one side they did really a realization of a tens carry in a addiator-like device, And you can do this multiplication without doing all this like I did it in the ideator. You can simply pull down 5 times, but you have to count 1, 2, 3, 4, and for multiplication. For the rest, it's really pocket device. You have to be big pockets. It's almost a kilogram. It's very heavy. Other heavy devices are this computator or arith style. These are, in French you call it crémaillère. These are the dented rods, and you put them down. Interesting is perhaps to see this arith style. This is one of the older. This is almost at the beginning of the 20th century. It's interesting because there are some provisions to differentiate the tens complement at the right side, at the left side, because if you know it, when you can only add with this, and you add with the complements of the numbers, the tens complement, but the tens complement is for the upper right is the tens complement. The other are the nines complement. This is a difficulty when you see bigger machines where you have always only the 9 complement on each button to press, and you have to provide at the rightmost position. You have to not to pull the 9's complement, but the 10's complement, one above. Here is to the right are the complements. This is from 1 to 9, and here you see from 0 to 9, from 1 to 0 and from 0 to 9 at the right. At the left are the 9 complement, at the right are the 10's complement. Because normally you have the number ordered to the right. Yes, golden gem is a really chain adder. There's a continuous chain. Very similar are these recent development of Resulta. It's not really portable, but it's small, let's say. Or this almost a toy calculator, this Schnellrechner. Development already proposed in this kind at the beginning of the 20th century. Interesting is perhaps a small stepped wheel calculator, which was advertised. Mit dieser Maschine machen wir Schülern das Rechnen leichter. For ease of calculation for pupils. Maybe I find you have inside you have the step wheels, and you pull out the number you have to indicate, and you turn to the right and you have to count 1, 2, 3. I wrote it over there because you have to speak it or to think of what you are doing. And I think it is really interesting. This makes easier for pupils to think, because in general I like the mechanical calculators, in general bigger calculators, because there is an intuitive difference between the left. That's that when you multiply something at the left, you have a number, abstract number, but you indicate the number, you see the number, but the right multiplicand you have to think of, and you do an action on this. You do an action on another number. 5 times turn something. And this is, for me, it's very interesting for didactical reasons. Children do it intuitively, but they are not thinking of mathematics, what they are doing with the transitivity and so on, all these mathematical concepts. Yes, this is a small device. It's interesting. And at the last, I show some newer development, the newest developments. I begin with the Alpina. Unfortunately, it was one of the less successive developments. You see it when I'm using it. It's really, let's say, a little bit difficult to use. Halb. Good. You see, this is not so very easy. This is very small to the indicator, and it is very for specialists. It's very interesting how it's devised and how is the internal functioning. But really, for using it in every day, it's not so interesting, and not so useful. I think one of the reasons is of the unsuccess is this kind. A little bit similar is this multifix. Perhaps you saw it. You have to fix it even with the hand because it's and you have not even a turn crank, but a lever to pull down. And last not least, we have the Curta. Yes, the Curta, perhaps you have seen how to work it. There are so many explanations in internet. You see it, how it works. I did some calculation. It's intuitive how to calculate, and was very used even in some difficult situations. For example, in rallies, they used it because they could use it by hand. Perhaps I can do a little bit anticipation. One of my ideas for the next meeting, I would like to present my development. I did it already 10 years ago about a kind, I call it ontology of calculating devices with a net of nodes meaning some indications or photos, and this is an explanation of This is an explanation of the Curta. All these kind Curta is from this one, and the photos and so on from Switzerland and so on, and even development from the ordinary the system of one. Yes. Thank you.
We had quite a number of machines, devices. Is there something specific here to ask? Questions?
I wonder, Wolfgang, are there any mechanical calculators made for the binary system?
For binary system? No. No, because the binary system was interesting only at the development of computers. Of course, the first computer, mechanical computer, was from Zuse, who did it, but he realized it with the intention to do a real calculator, and it's very big. This is one of the difficulties is to do here mechanically, for example, a tens carry, or some logical, this is let's say even the tens carry is a logical problem, and she realized it with some, device. There are even some replica, not replicas, some prototypes, some experimental devices which explain how it works. This was presented in one time in.
Let me briefly answer that. It's not very interesting because you only have a two carry. So, but what exists are octal and hexadecimal very getting. So you have an 8 carry or a 16 carry. That makes sense again for the various applications. Okay.
Perhaps in addition, the machine from Johann Helfreich Müller from the late 18th century was, I imagine, the first one which could calculate binary. It has interchangeable systems, so you can calculate in a decimal and in a binary system.
Okay, now.
Oh, this is interesting. I didn't know. What is the name?
Johann Hilfreich Müller.
Behind?
Hilfreich Müller. Die haben wir
Hilfreich Müller. Yeah. Excuse me.
Looking at all these small devices, I always wondered, they are all beautiful and everything, but some of them are much, much superior to others. For example, the golden gem adder is way better than the Ariato.
Yes.
People keep trying and making more and more machines that are less good than what you can already get. What is your thought? Why are they doing that?
Oh yes, to differentiate. one had to invent something new, and you cannot let it. Just, for what reasons are so many different cars? One better than the other. I cannot explain it. Yes, I saw it really. This is sometimes very difficult to use one, or more difficult to use one than another. Yes, I hadn't shown it because of lack of time. How to use the golden gem? Yes, but it's intuitive. You pull down the number and it continues. But even this is if you have 8 nines at +1 with you cannot do it. You have to help it from one position to the other. It stops at half.
Okay, thank you, Wolfgang. Said differently, Shakespeare's plays. That's the plan for next year. When? Well, it's always sometime in September, at a date very similar to this year, namely 21st and 22nd of September 2018. So everybody, please take out your calendars, your agendas, and write it down. What? Oh, yeah. So, and again, we have a theme, and if it's Shakespeare's plays, it has to be something with that. So it's from sonnets to sums. Okay, you know what to do. Everybody, take out, go to the bookshop, read your Shakespeare again, find good quotes to make nice presentations. Yeah. Everybody has to do so. So you recognize the quotes during the presentation, please. Yeah, it's at the Stratford Hotel. The Brit and the English have also a certain tradition, namely to make a display that is to call out and for people and bring along their specific thing for this theme, for display, and that is early British rules and secondly long scale rules. So again, dates we need, a certain notice to intend the paper so that they know what's going on, deadlines and all that. And the important thing is they're really hurried to have those things, everything ready. You can read that all on a website. But first, I have to give a warning or an information. First, there is this place, Stratford-upon-Avon, south of Birmingham. That's the place. But there are several other Stratfords in Britain. Please, Stratford-upon-Avon. What else is on the map? There is a place called Milton Keynes, which is actually not meant, but a place nearby. Actually, a place nearby, something about here, yes, where we already have been in 2012, namely Bletchley Park. And this is just a reminder, anybody traveling to Britain, that they have there the National Museum Computing, and of course, there's also a display by the UKSRC. sponsored by the UK, a slide rule collector. So go along there, have a look even more, and if you've been there, just a refresher, because lots of that is refreshed because many things there belonged to Colin Burns and were sold a year ago. So plan your trip. This is a view of the hotel. And most important is, next to the date you wrote in your notes, that you write down this web address, this URL, UKSRC or UK, you should know that, and IM 2018.